Yeah, so good evening everybody and welcome back after the coffee. So we have this panel with 4 speakers, derivatives from space mapping, scope of downstream applications. And before we start, I'd just like to mention that as a growing up student, I was pretty inspired by the works of Dr. Mukunda and Dr. Rajaram Nagappa, especially because they're ex-ISRO, and I've read a lot of their papers, and that's what inspired me to get into space. And I'm today privileged to be in a session together with them. So I'd like to welcome all the speakers here, and I'll start with Dr. Indranil Sarkar, who's the senior. He's not here. Okay. So with Dr. Jaya Singh, who's the director of BKC IRNSS Private Limited. So that, just as an introduction, Dr. Jaya Singh is an entrepreneur, educator, and author with over 18 years of cross-functional experience in academia and a range of industries, including biotech, environmental sciences, and public health. She currently drives strategy and R&D at BKC IRNSS Private Limited, India's foremost meteorological company focused on providing innovative technologies for disaster management, agriculture, and renewable energy. Prior to her move to India, Jaya was on the faculty of Harvard Medical School, where her research program was focused on DNA sequencing technologies. At Harvard, she was involved in shaping policies for academic advancement. Jaya has published widely in areas of chemistry, life sciences, and environmental sciences, public health, and is an award-winning educator. Jaya also serves as the director of R&D for Save a Mother Foundation, a non-profit organization focused on providing healthcare solutions for rural populations. Jaya earned her PhD in chemistry at Brown University, USA, for work on origin of life theories, for which she received the Potter Prize and a fellowship from NASA. So Jaya also has a BSc in chemistry and St. Stephen's College at Delhi University. Jaya, please.
Is that all?
So Jaya, you have every speaker has 10 minutes, so that we are left with about 15 minutes for questions at the end.
You know, when I was coming here, I was speaking to a mentor, and I said, you know, I've been invited on this panel to speak about weather forecasting and space weather, and what do I know about these things? Not much, really. And he told me, he reminded me of the story of the professor going to a Zen master and saying, I have so many questions, I want enlightenment. How do I learn? And the Zen master comes back with 2 cups and says, I can answer your questions. First, let me pour tea. And as he poured tea, the tea started overflowing from the cup. And finally, the professor said, what are you doing? You're wasting this tea. And the Zen master said, well, that's because your mind is so full of ideas. You have questions, but your mind is already full. How am I going to answer these questions? And that's the feeling I have about space right now. There's a lot of dialogue, conversation, but there's a lot we don't know. And any time to really dig at a question that we don't know about much, the first thing is to have an empty and clear mind. And with that tone, I'll spend the next couple of minutes telling you a little bit about what we are doing, a little bit about what I know, and what I know is our story, and I'll capture that in a minute. Can I get the lights out, please? Okay, this way. Lights down. The lights down. story, we think we know, but we don't really know how we got here to Habitat Center this afternoon. And I want to go back. When I talk about Habitat Center, I also know that right now, my GPS tells me we're right here. The little black dot is our solar system. The galaxy, the center is the galactic bar. And our solar system goes around this galactic bar every 225 million years. So with this context, with this stage, I'm willing to accept that I really don't know much about what's happening with our planet and weather systems. But this is the context. This slide was prompted by my son, who said, "Mama, more earthquakes, 7-year-old child, volcanoes. Can you tell me why it's happening more? Is it happening more? They're shifting magnetic poles." So the real question is, yes, we are in an environment where we haven't been before. What that means for us is something we all have to collectively address as we move along. There are downstream applications. Are there? Sure. I can pull out the laundry list of those applications. But the question is, how do we get there? How do we start addressing those things? And on that background, I'm going to talk about weather forecasting and beyond space policy. What gives us the gumption to stand here is we are an old weather technology company in India, 25 years in the business. And the very fact that we've survived and have thrived with support from some of the people on the stage here gives me hope that we will survive and make it to the next space age. What are the questions we started addressing when we started? A 7-day forecast for the Indian subcontinent that could be made available widely, quickly, rapidly to a whole slew of people. That's where we started, and where we are headed now is very clear. And this is a perfect forum because we need a number of different minds to work together in order to address some of our pressing problems. We come with expertise in weather forecasting, software for automated forecasting that has been applied to a number of areas, as well as instruments. And with the support of a number of institutions, I'm standing here on the stage, the application areas are multiple. Agriculture, there was a discussion on seismology a few minutes ago. And of course, human health. If our weather environment, atmospheric weather, as well as space weather, is having such a bearing on our planet, our dynamic planet, it's also having a bearing on human health. That's the holistic picture. We are chipping away at each one of these points. But today I'll just share very rapidly what kind of work we're doing in agriculture and why we're picking agriculture. Decision support systems in agriculture have been around for a while. Another story I want to tell, bringing, is the Irish famine that happened over 100 years ago. And what it was, it changed the course of history, was a blight of potato. It's a fungal disease. And now, in 2015, the Irish Met Department issues a warning that environmental conditions are prevalent that can result in this disease. 3 to 4 months in advance, there are interventions, problem can be solved. This is really topical to India, not only because basmati rice will move world markets, but also, it's integral to the livelihood of a majority of the population here in India. Problem statement, everybody knows. Challenge is, how do you implement? And the number of people working on this problem. Our little contribution to this has been that we've brought, since we say we understand some of weather science, we also understand, we've been curating the entire scientific knowledge base for crop science in India, and we have brought it together on a GIS platform. So then you can start looking at crop weather relationships in an automated, scientific manner, and with a push of a button, warnings can be issued, farmers can track their crops, as well as on a larger system, on a macro level, you can estimate production of any crop at any given time. How good are we? How accurate are we? Well, we can only be as good as the data we have access to, as the data that people collect. So those are our key bottlenecks, and they haven't really, they've shifted a lot over the years, but there's still a tremendous amount of work to be done in that area. This is our vision. Again, I'm just giving you the example of agriculture, just one problem. agriculture, we're not the only player, a number of stakeholders are working on this. But it will take inputs from multiple sources, multiple agencies, in order to really do this on the scale that India and perhaps the globe needs such solutions. And to do that, we do need to have partners and stakeholders who are talking to each other. Our challenges, everybody knows: instrumentation, data sharing, and then into operational R&D. The picture you're seeing is the classic picture of how weather forecasts work. But now we have to move beyond, because as soon as you shift the perspective from this visual to this, the whole context, the whole playing field changes. So I'll leave you with these thoughts, and happy to answer questions outside, scientific, and there are luminaries on the stage who can address scientific questions. Thank you for your time.
Thanks a lot, Jaya. Now we have Dr. LS Rathore, Lakshman Singh Rathore, here with us, who's the Director General of the Indian Meteorological Department and the permanent representative of India with the World Meteorological Organizations and the United Nations. Dr. Rathore Singh obtained his degree in secondary and senior secondary education from Jodhpur and bachelor degree from Bhopal Nobles College of Udaipur. Dr. Rathore completed his master's and doctoral degrees in agriculture from Rajasthan College of Agriculture, Udaipur. He's joined the IMD in the year 1980 as a meteorologist and played a key role in setting up weather-based agriculture advisory service in India.
Thank you, Dr. Narayan Prasad, my co-panelists and friends. Good afternoon to all. As we all know that meteorology is the prime user of space technology. And today in this hall I am reminded of one audit question which was posed way back in early 80s to space scientists, that government of India is making huge investments in space, how this is being used. And we were found on a back foot. We were using at that point in time only cloud imageries and those kind of basic products in our day-to-day operations related to weather forecasting. From that point on, now our entire gamut of weather forecasting processes are primarily driven by observations derived from space. Globally, the weather forecasting working groups are numerical models, and therefore in these models defining initial status of atmosphere is the initial point, and that's how you define the initial state of atmosphere. And that initial state of atmosphere is defined through observations. And since we have very sporadic ground or upper air observations, and we got observations from oceans, two-thirds oceans, mountains, deserts, poor countries who are not able to manage meteorological observing systems. So we are left with the space technology. And today in India, we are processing every day almost 35 gigabytes of data generated by satellites. And that is how we are able to define three-dimensionally the initial conditions of this atmosphere. And we are assimilating radiances. To begin with, we started with so many other kind of products, but now they have graduated to assimilating a better information, because through space we are just trying to estimate the spectral signatures. You are not measuring temperature, humidity, pressure, but you are measuring some signatures and translating them into some product which is of importance to defining the atmosphere. Now, we are confronted with everyday new challenges, both in terms of modeling aspects, in terms of observing systems, in terms of assimilating observations. And since we are talking primarily on the derivatives from space, I would just mention as to, in our process of this mapping of atmosphere, not only atmosphere, we also need to map oceans. We also need to map land and land surface, because it is the land surface process and ocean atmosphere coupling which are equally important, if not more, to understand the both dynamic and physical characteristics of atmosphere. And therefore, as a meteorological community, we are really confronted with challenges in not only defining the ocean state or land state or the land surface processes, but the dynamic behavior and how they are coupled to the boundary layer atmosphere in particular, and how that is transmitting, the impact is transmitted to the middle troposphere and upper troposphere, and how from stratosphere and ionosphere, troposphere is being impacted. So it is from three-dimensionally we are trying to estimate the impact of various constituents of Earth system size onto the atmosphere, and therefore mapping is very critical. We are grappling with a number of aspects related to monitoring from space. Vegetation is one aspect, soil is another aspect, because both the soil moisture and soil temperature coupled with vegetation indices determine the boundary layer processes, besides many other applications. So therefore we are really trying to have a better handle on mapping these aspects, and not only they are impacting atmosphere, but from other applications which are related to agricultural meteorology, we need to know as to what are the stresses on the crops, both biotic and abiotic. So mapping of those stresses are also equally important. The oceans, we are the spectrometer and the other data available are helping, but we need to have a better handle to generate the continuous mapping of the oceanic surface, not only surface, but as to how the thermal energy, ocean thermal energy from beneath is impacting the surface and how it is coupled to atmosphere. But equally important is generating products which, beside the forecasting and defining the initial state, the monitoring itself, for example, in terms of rainfall, precipitation. We have been using various products starting with TRMM, and then we are generating both in terms of total quantum of precipitation and density and duration, etc., of the different episodes of the precipitation. But we need to have a better handle on those aspects, and particularly in the context of extreme weather events which are increasing, and also the impact of these extreme weather events on various aspects, including agriculture. For example, the crop damage which is accrued either because of low temperature, high temperature, strong winds, heavy precipitation, hails, all these events. So first you define as to what is the extent of particular meteorological event which has occurred, both in terms of the spatial and temporal extent, and secondly to map as to what extent that has impacted the crop. And these are the key questions which are now being, in order to do the crop risk management and insurance and those aspects which need these data at a much finer granularity, and I think the only answer is through space technology. So these are the challenges we are confronted with, and I'm sure we should be able to address jointly, because this house is brainstorming and house is the combination of various scientists drawn from various disciplines, I'm sure. And thank you, the organizers, for inviting me and sharing my thoughts. Thank you very much.
Just before I introduce our next speaker, as you would probably all know, India is coming up with its own regional navigation satellite system. And we all know how good GPS has done for the civilian space and with our smartphones and all the devices. So now we have Professor Rajaram Nagappa to talk about the IRNSS and its downstream applications and the potential of using the regional navigation satellite system for it. So Professor Rajaram Nagappa is a visiting professor and heads the International Strategic and Security Studies program. His background in aerospace propulsion, and he has held senior technical and managerial positions at the Indian Space Research Organization. His current interests span in ballistic missiles, cruise missiles, space and space security. Professor,
I'm more good at pushing satellites into space rather than talking from derivatives of space. This one, but a bit difficult to say no to people like Raji. They have great perseverance capability. And GPS sort of has revolutionized the way we find our way from place to place. It's so ubiquitous. And as the chair mentioned, 3 years ago, I think 4 years back, when it was my son-in-law had to buy a unit for $100 or so to keep in his car. Now I think in your mobile devices you can go from place to place. It's become so ubiquitous. So if GPS is available, why should India or somebody else develop another Indian regional navigation system? This becomes the question. Then India is not the only one. You have other systems available. GLONASS is available from Russia. The Galileo is there in the European this one. China is coming out with their compass systems. GPS is operational, so is GLONASS. The others are still in the implementation stage. And therefore we start looking at why should we do it. Main apprehension at times is more from a security angle. If you rely on it is for certain applications, there's a possibility of deniability. And what you normally get is not the precision use of GPS, you don't have the access. This precision code lack of access does not give you a great amount of accuracy in certain guidance requirements. And therefore, if you have your own satellite, you can address some of these apprehensions. But also there's certain, the initial navigation systems on board many of these vehicles. It calls for a certain level of precision, and therefore adds to the cost. But if you have a reference like the GPS or the IRNSS, maybe you can do with a coarser system, and therefore attendant cost and effort saving come into the picture. So India's entry into the satellite navigation, actually two domains. One pertains to what we call the GPS aided geo-augmented navigation system. This is called, abbreviated as GAGAN. So GPS aided geo-augmented navigation system, and the other one is the Indian Regional Navigation Satellite System. Now they are able to overcome the lack of accuracy and the integrity required for safety of life applications. I mean, the predominant this one on the GAGAN is the safety of life application, so that the aircraft safety you can improve quite a lot. And of course you have other various attendant advantages in using other transport systems. But essentially the GAGAN functional requirement is tuned to the aviation requirements as such, and it will meet the accuracy, continuity, availability requirements. I thought I'll not go through the slide because I'll just this one. So if you look at the SBS, as you call the satellite based augmentation system, its accuracy, integrity and availability are there as a major this one. And the data from the GPS constellation, it actually uses the GPS constellation data. It needs to be improved to meet the stringent aviation requirements. So a number of countries have their own satellite-based augmentation systems, and India Gagan does the same, this one. A major advantage it provides is a 24/7 all-weather type of capability, gives you improvement in the vertical clearance, and from the course up to about 30-meter resolution type of thing which your GPS would give, it improves the accuracy from 1 to 5 meters of that order. And if you have a better vertical clearance, you can therefore, in terms of the air traffic control goes, you can manage with more aircraft landing and takeoff in a safer fashion. In the process, of course, I don't know whether to say fortunately or unfortunately, it's all in the ISRO sector, because ISRO has this specialty, so they have done this one. There are 15 Indian reference stations co-located mostly at airports. There are 2 Indian master control centers, 3 Indian uplink stations, 2 chains of network stations, and 3 geo satellites. This will be 8 and 10 are there, and the third one as a standby, which are into this total loop of managing. It's something like this. So you have the 15 reference stations giving the data to the control centers, from there to the uplink stations, which uplink to the geo satellites, and through the GPS directly to the users. Now the major benefits that Gagan provides is the all-weather, as I said, operational to all qualified airports. It's improved operational and safety and efficiency, obviously it improves. Enhanced direct navigation for all flight phases, that is en route, arrival and departure. Coverage of all altitudes ranging from surface to 30 kilometers altitude. Navigation service to other sectors, helicopters for example, commercial, this one they can also use. Curved segment precision approaches, leading time and fuel efficiency, and reducing the separation standards, allowing increased capacity in the airspace at low risk, reduced risk, and meet the obstacle clearance requirements. And it essentially improves the efficiency of the air traffic control system. And one major thing is this is totally interoperable with other similar augmentation systems. Comes to the Indian regional navigation system. This is also, we have 3 segments: the space segment, the ground segment and the user segment. The space segment comprises 7 satellites. 5 of them already are in orbit. 2 are planned to be launched by March of this year. If you look at the other, this system covers essentially the regional, the Indian landmass and a range of 1500 kilometers around the landmass. So it's essentially regional in purpose. And out of these 7 satellites, 3 are in geostationary orbit and 4 are in geosynchronous orbit, located at different latitudes. And the geosynchronous ones are at an inclination of 29 degrees. But all these 7 are totally 24 hours within the radio visibility of the Indian stations. The ground segment comprises of the spaceport control facility, which monitors and controls the navigation satellites. It also uplinks the navigation data to the satellites. In addition, we have the navigation center, the CDMA and the laser ranging center, network timing facility, and the clock ensemble, which includes hydrogen masers and cesium clocks. Extremely accurate atomic clocks are there. And the receivers, the user segment comprises of receivers, both in the L5 and the S band. So there's the standard code which is sort of available to all users, and there's a restricted system which is encrypted signals which is available only to authorized users. And the accuracy is of the order of 20 meters in this. So there's the transmission is in L5 band and in S band. So you have a single frequency receiver adequate for the SPS, that is the standard precision, this one, and the multimode GNSS receiver compatible between IRNSS and other service providers like this. Similar to this, also certain amount of interoperability with GPS, GLONASS and Galileo exists. So the general applications are very well known to everyone. So vehicle tracking and fleet management. So these were perhaps we could look at. The en route and approach for aircraft is known. It can give various other this one, help in fisheries, mining, management of fleet movement, collision avoidance for railways, town planning, road alignments, GIS, power grid synchronization, automatic braking. So this is where I think to broad base these applications, perhaps where maybe other players could come in, monitoring the health of the. So how exactly, when I put monitoring the health of long bridges, tall buildings and tall towers, exactly how to make it happen, or the precise farming and dispensing in these applications, how other players could come in would be a useful input. As I said, these are all, apart from this one, there are a lot of spin-offs of this variety which could perhaps be used in much more this one. Same way in terms of space geodesy, earthquake type of seismic movements and like that, earthquake mechanics, polar and glaciological studies, atmospheric weather and ionospheric studies, as well as the for the space, this one, these are orbit determination and all the things have come in. So this will be of some use. So in these applications where perhaps more effort could be put in. Thank you.
So just to set a stage to Dr. Mukund Rao, India operates one of the largest fleets of Earth observation satellites in the world, and we have a huge history with starting from the IRS initial series of satellites. And in last year in September, the Indian government, the new Indian government, set a stage for 60 departments of the government to identify 170 projects where space technology can be used, and a number of them will probably use GIS in many of them. So to give a brief on the national GIS and its policy perspectives, to have Dr. Mukund Rao, who is the adjunct faculty at National Institute of Advanced Studies. Dr. Mukund Rao is an expert with more than 34 years of unique government industry consulting experience in Earth observation, GIS and space. So he has a MSc Geology and PhD, and he served with ISRO for more than 24 years, where he was involved in shaping the Indian remote sensing program and providing leadership for various EO and GIS programs.
Thank you, Narayan Prasad. Let me thank ORF and Rajiv for giving me this opportunity to come and share some views on policies. We have been listening about Indian space policy and now GI policy. I must mention that in NIAS, we are a small group of people, myself and my colleague Sridhar Murthy, who have been working on the issue of space policy for quite some time. If you visit the NIAS website, which you should be able to access, you will see a lot of documentation on what is involved in a policy. And as Ambassador Sood had earlier asked, what are those issues of a space policy? So some of these studies we have been doing, and we have looked into this particular aspect of a GIS as a policy perspective. In the next 10 to 12 minutes, what I'm going to do is I'm going to do some mishmash. I'm going to give you a perspective of what is involved in making a policy or defining a policy, some examples of that. I'm also going to tell you about a trust that is required in India. This is again India-centric, in the area of Earth observation, and if India has to push a lot of usage of high technology like space images and ICT tools into governance, what is involved, and where does space play a role for that particular activity. And I'm going to lastly talk about some gaps which are there, which need to be plugged in, and which becomes a part of a policy outline that is there. So let's start. We have some of the best Indian satellite operations, and they provide satellite images on continuous basis, but that's not just enough for doing any of these applications. Way back in ISRO, we realized that if we have to push satellites and the space technology, it's the application that has to be really developed and built in. So if you don't trust the applications, you don't take the applications right to the grassroots level, into the individual's hands, the technology lies in the laboratories. So there was a clear recognition that just generating satellites, making satellite images or making positioning satellites is not going to be enough. We very early realized that all these satellite images had to be clubbed with a lot of other data. Some examples you saw, which Dr. Rathore and Jaya also mentioned about fusing data. So there's a lot of ground data. And in India, any decision that needs to be taken, if you don't have the property information, that is what is known as a cadastral, it makes no sense to any administrator. So we are talking of fusing, on one end, space technology, and on the other end, a variety of data sets, which ultimately is what the final governance or decision maker wants. There's a big gap. And this is the gap that we have been talking in the last few years, saying you need to bridge this gap in India. And in India, if space technology is not very widely utilized, or if applications are not getting developed because of this gap that is there. This is unlike in other countries. In United States, ask any data for any part of United States, you'll get it. So decision makers don't have to struggle for the other end of the spectrum to get all this data. And that's where we talk of a midterm enterprise, a national enterprise to create what is known as a national GIS. And this has to be a standard, a sort of a platform on which all common data would be available for the whole country. So that's the vision, and making everything GIS ready so that you can model it. Now put it into computer models, weather models, as Jay was mentioning, or Dr. Rathore was mentioning, or some other agencies are talking of, and develop applications. Decision support applications. The final user wants decision support applications. And you see how far the decision support application is from the satellite technology. So the final user does not really want to access the satellite technology per se, but he wants access to the decisions which he can take and say, where should I cut a crop? Where should I sow what seed? Where should I put a bridge? Where should I put a road? So this whole system of understanding all these mechanics and making it governance oriented and reaching the grassroots level is what the National GIS program is of. The technologies involved are quite complex, and I must say that it starts with satellite image. That's the trigger point. If you don't have the satellite image, you wouldn't be talking of many of these areas. It involves surveying, mapping, geodatabase, positioning, and a variety of other things. So just to give that this is the type of final enterprise that will have to really trigger the use of space technology, which is satellite images and positioning and communications, to reach to the final grassroots applications of decision makers. And this is the vision that India has developed of what is known as a national GIS. And what is a national GIS per se? It's just a seamless database for the whole country, which is systematically developed and made available on a platform. It's like a highway. So you just build a good highway and you allow the traffic to flow on it. This is a platform which will allow seamless data to be available for the whole country. And once you have this data platform, applications anybody could develop. It could be the weather applications, it could be agriculture applications, and so on. This is a program that the government of India is already considering and very soon should get into position. And I must tell you what I'm hearing from it is almost about $500 million worth of project that's going to get done under this National GIS program. So a lot of investments are going to happen to reach the benefits of some of the modern technology right to the governance level. What does this do basically? Basically, it's something like helping applications. So you create a platform, the platform is accessible to anybody who wants to come and ride on it and develop your applications. It can be for governance, it can be for citizens, it can be for enterprise. Whoever wants to use GIS or satellite images and positioning, he comes onto the platform and accesses them. So it's a common platform that would make available access to these data sets and the ability for anybody to develop applications and even put those applications also on the platform so that others can use it. So that's the vision that is there. Now let's look at, if you have to develop this, we also looked at some of the policy ecosystem. India has a fairly long mapping experience. India started mapping sometime in 1600s. There are historical records of mapping in 1600s. But we have come through a long process. And in 1980s, when we have the satellite, Earth observation satellites, we saw the benefits of taking this down to the ground level. And it has taken almost 20 years to come to this vision and then develop a policy. But India does have a policy. I just want to make this point clear. We should not all assume that there is no policy at all. There are policies. There is a policy, but one may feel that there is a flaw in the policy and may want to improve upon it. Just to highlight, there are 5 of these policies. I'm not going to go into each of them, but I'm going to highlight on one of them, which is the remote sensing data policy, I think, which was talked of in the morning also. I must mention that the remote sensing data policy, to me today, it's really not a policy, except it is a set of procedures or a set of practices that anybody will employ for distribution and access to remote sensing images, which the Indian Space Research Organization prepares. So it's more an operating procedure, but way back in 1998, it was made into a policy and it has continued, and 2011 it is there. But what I want to mention is, way back in 1998, the policy recognized of privatization. That is the shift that was brought into the policy, saying that privatization of remote sensing and earth observation should be a part of the policy system. But yes, nothing much has happened, and that's where I think we need to learn and look at what are those gaps that have come in. The policy is, many say, is restrictive, some say it's quite limiting and so on. But yes, today in 2016, a lot of improvements can be done. I must mention that particular thing. There is a gap that has also come in the sense that the policy had said that the government is committed to provide a continuous remote sensing program and make available that data to the citizens or to the platform that we are talking of. That has also taken a beating in the sense that when the policy was done, ISRO had the best satellites in the world. But today, the best satellites are somewhere else and the policy is lagging behind. So there have been gaps. The policy, what was visualized to bring privatization, has not happened. The policy that was visualized to keep pace with what the world is doing has not happened. But the policy has at least brought in a method of distributing data in the country, and there are a lot of improvements that are possible. Just to give a summary of all these policies, the long-term commitment, I think, is what is most important for a policy. And most of the Indian policies that I have seen are all short-term, 5 years, 10 years down the line. But we need policies which are far-reaching, maybe 20 years, 25 years down the line. The growth impetus must be very clearly defined, and that is not done. All practices and methods of working, standard operating procedures become policies. They are not policies. Policies must have a growth impetus. Is the policy for promoting industries? Is the policy for industrialization? Or is the policy for social commitment? Or is the policy for technology development? I think that has to be ingrained into the policy, and I think some of those things we really need to learn. There are cross-cutting issues, and today you can't talk of a remote sensing data policy without looking at UAV policies. You can't talk of UAV policies without looking at GIS policies and so on. So there are cross-cutting issues that one needs to consider in the policy definition. Clear do's and don'ts. I think this is what is lacking in most of the Indian policies that we have seen. Clear do's and don'ts get defined, and I think this was a point which was discussed in the earlier panel also. And this is what in NIAS we studied and said, if for NationalGIS we were to work out a policy, what would it mean? Actually, we went with a parametric approach, and we feel this is the best way of looking at a policy, and tomorrow Sridhar Murthy will tell you of a similar parametric approach for an Indian space policy. We identified what parameters are important for the country to look at NationalGIS, and we identified 7 areas: imaging, positioning, advanced survey, which could be UAV surveys or ground surveys or whatever, etc., mapping, GI software, geographic information software, and the capability of doing this one. We identified sub-parameters into all of them, and something like 64 parameters were identified into identifying the policy and access the report, and we can discuss it. One of the things that we feel is most important is this long-term commitment of satellites, the best quality satellites that is there, which either through homegrown satellites or through satellites which are outside available and which can provide the data. I think this commitment the policy has to very clearly define in the NationalGIS. The second one is the privatization. Privatization is a thrust that we feel if NationalGIS has to grow, it has to reach 6 lakh villages, and in each village the people have to access this for decision making. It is going to be through the process of privatization. So there are various other parameters in terms of licensing, competition, and other things. We have identified all of these elements in the policy. There are some cross-cutting issues one must always consider in policy, and specifically in space. There will always be national security. What is the national security and what are the control issues, legal issues, social issues, or IPR and other things, and maybe even industrial capability, building industries, like there was a discussion, how do you build industries? How do you make ISRO move away from its own development of PSLV so that tomorrow and industry starts developing PSLV. It's a capability building. It won't happen over short periods of time. So you need to build all these elements and then define a policy. And this is exactly what we have done in the National GIS policy, which you can access on our website. And what does the policy talk of? It is basically nothing but a set of do's and don'ts, which are very clearly defined for the National GIS in this activity. It has a remote sensing element. It has a national map policy element, which is for maps and so on. It has the aerial survey policy element, survey guidelines, and some legal issues also. Always a policy has to consider this in totality. If you don't consider this in totality, you're missing out somewhere, and some legal issues, contractual issues, commercial issues, etc. come in. So this sort of a policy has been defined in that sense. So from this perspective, what we feel is National GIS, if we develop and what is going to be approved, it will be a good program to bring in accountability to governance, because you're assuring the country of the provision of space technology products and the advanced derivatives that come out of it to the citizens. You're empowering citizens to access them and do what they want with the data. You're creating a knowledge enterprise, which is a very high-end knowledge enterprise for this activity, and hopefully develop a global leadership in the area of geographic information, Earth observation, and so on. So that's the broad vision that the National GIS hopes to have. In summary, we feel that space technology is a very important element of the national ecosystem, but if it has to move on, it is the application that's going to drive. And in this case, in National GIS, it is an integration of Earth observation images, the positioning, and the ICT tools. And an integrated National GIS, by the way, would also create a demand. Once you have a platform of all this available data, it's going to create more demand. More satellites are going to be demanded, more resolution data is going to be demanded, so it becomes a chain in that sense. And of course, it has to be market-driven solutions and services, because once you have a platform, you should allow any public or any private citizen to come on and develop the applications that are required and make them available in that sense. And ultimately, the benefits must go to the citizen. So this is in short sum and substance of what I wanted to talk about, just to give a feel of what this National GIS is about and how a holistic policy can be developed, and what are some of the tenets moving from remote sensing data policy into some of these larger policy domains that India has to look for in the next 20, 30 years. Thank you.
Thank you, Dr. Mukund Rao, for your explanation. I would invite questions to the panel, and let's take 3 in a batch as we continue from the previous panel. Yes, sir.
Brett Biddington from Australia. My question is to all of the panel really, how much is enough in terms of investment in satellites or other sensors and other systems for meteorology and for land use and land use planning? It seems to me that if we're not careful, we invent in these sort of things a self-licking ice cream. We buy more because we can have more because they're a bit better, but how does that actually improve what we're doing? You know, there comes a point when we get to a law of diminishing returns in terms of the value of what we provide to the people. On that sort of curve, where are we with regard to weather and meeting India's requirements, and also with regard to land management and GIS would be my question.
So I'd invite Dr. Rathore to first give the metrology and then the GIS expert.
How much is enough? Enough is enough. I think the approach we have to have is, we already have a consortium, but notwithstanding that different countries are making investments, of course, to meet their country requirement, but on the aspects about which information or data are already generated by other countries. As Dr. Rao mentioned, we need to have a policy, and investment will depend on what approach you follow. If you have, like as of now, we have 6 countries, which we a consortium group of meteorological satellite. I'm talking meteorological satellite. And we are doing duplication to a large extent. I think we can cut that, invest to probe those realms which are hitherto untouched. And that will determine as to what extent we should invest.
You know, what I feel is the cost of all of this in an Indian perspective is not too outrageous. In the sense, today in India, the cost of satellite image is about $1 per square kilometer from the Indian system. If you try to buy it from a commercial system, which is from outside, maybe it would cost you about $20 per square kilometer. So that's the scale difference that comes in. But then a investment of $1 per square kilometer into the satellite image and then value adding it about 10 times to create the value addition that we are talking of is reaching it to about $10 to $20 per square kilometer to create this whole enterprise in a sense. But then the advantage that you have is you don't duplicate it. For example, the meteorology department is not going to do the same thing again. The industry is not going to do it again. The agriculture department is not going to do it again. So there is a saving that comes in because there is a common platform available, point number one. But then this platform triggers a lot of development activities. It will trigger smart cities. Now every city needs this data. It needs this packet that we are talking of. And there the investments are very high. Each smart city they're going to invest something like 100 crores, which is something like $15 billion and so on, and $1.5 billion. And if that is a scale, investing this sort of a thing is not at all going to be in any way outrageous. But I think the thrust is if you don't invest this $10 that is there, you're not getting the benefit reach out to the governance at the lowest level. So there is also a social good or a merit good of this investment that is there, apart from the public good and the commercial good that comes in. And if you integrate all of this, I think that the value of this good is very high and it's very cost effective in India to look at this total system.
Yeah, Jay.
I was not clear enough about the GI policy in place, or is this something that you're proposing?
Okay. The Department of Science and Technology asked NIAS to develop a policy perspective, and that's what we have done. And we have given this to the Department of Science and Technology, and they are now taking it up within the governmental system for getting the approvals, which I think is in process. So in a way, the policy would get implemented through them. We have been like a think tank agency to do a policy analysis and recommend what would be the best approach to develop this national GIS.
Okay, great. No pressure. What time frame do you think a final policy determination might be made?
The National GIS program is the first development of this whole thing is planned for about 3 to 4 years. So that's the total program. But from a policy study perspective, the study which we did in about 6 months. So to look at all the things and come out with a policy analysis and do that sort of a thing, like a think tank study, we did in about 6 months. But the National GIS program, which will implement and actually operationalize this policy, is going to be done over 3 to 4 years.
Great, thank you. A second question for Dr. Rathore and Dr. Singh. I've been in India almost 3 years now, and over the course of my stay here, I've seen an evolution in India's weather enterprise, where there's been a change of perspective of how the government perhaps works with private industry and vice versa. And also through that course, I've seen several commercial weather companies pop up, literally be formed and starting to use data for applications. So if either of you could ask the other one question, what would government ask private sector to do, and what would the private sector ask the government to do? All again in the sort of vein of a cooperative weather enterprise.
Ideally and globally, the National Weather Service, National Meteorological and Hydrological Services, they are responsible for maintaining observing systems and generating the running global models and those kind of generating products at that scale. And the private sector do customization, suiting to the specific requirement of a particular sector or particular customer. And that is the model which is working fairly well. And there should not be any competition in that. absolutely no. And there is enough room for everybody, and that's how industry is growing. And as far as warning and alerts, they are concerned, it is a niche domain, because there are a lot of other ancillary questions and follow-up actions are entailed, and therefore that remains with National Meteorological and Hydrological Services.
Yeah.
So I think Dr. Rathore summed it up for all of us, but one word I think would be data sharing, and second word would be trust, that we are working.
Hello.
Pallav Bagla from Science Editor, New Delhi Television. I want to take off from the question of how much is enough. And I want to bring in the perspective from the major terrorist attack which happened in Mumbai, where the terrorists used the GPS system to navigate and hold India to ransom. So is there a need for some kind of a control and regulation on this whole system? And maybe Jacob can jump in, because the systems they used were American systems, and the person who provided the information was an American, which was David Coleman Headley. And now the information is now pouring in that the attacks really gave a lot of trouble to India. And I'm sure Ambassador Rakesh Rood would second a lot of what I have said.
You want to respond?
Yeah, I think the trend around the world is sort of to do some soft regulation, because without regulation, unbridled, unhindered development in this field, there is always the perception of threat, and that can't be denied. This technology in the wrong hands can be used wrongly. We have to accept that. But in the right hands, it has a lot of good to do. So you can't deny the good, because there is a small possibility of a wrong happening, in that sense. Let me take another example just to illustrate this. The same thing can be said for an automobile. An automobile can also be used as a terrorist activity, and then it can hit a building, or an airplane can hit a building. You can't control that, because that is something coming out of a abusive use of a particular technology. We need methods of tracking them. We need methods to regulate them. That is the way the world is going, and I think in our policy also we have a fairly good amount of regulation, authorization, permissions to do and to access all these data sets and so on. So the world is moving on those lines, and I think from an Indian perspective, that would be the line to take. But then the underlying principle which changes is, don't deny the good user, but do all you can for a user who can abuse it and maybe use it against national interest. But there's a challenge still, how to track it. But I think technology is improving on that, and systems can come in which can take care of these things. So regulation, yes, Pallav, I would certainly say some level of regulation will have to be with the model for managing all this.
Yeah, I mean, just to supplement what Pallav said, in principle what you say, Mukund, is true, and I accept it. But the fact still remains that when you said you want to keep the good, go after the bad, it requires a level of cooperation which we know doesn't exist. When we are seeing it every day. If that was not the case, it wouldn't be that for 15 years we can't come to a definition of terrorism. We've been trying to negotiate a convention on it. For 15 years we don't have a definition, so we know there isn't that level of trust, which is a prerequisite for developing the kind of cooperation that you talked about.
I would certainly agree, Ambassador Sood, and if you look at a national system, I think there can't be just one spike of a model developed. Everything has to improve, and you need that sort of technology in the defense agencies, security agencies. But then technology is also overtaking so much, so if you don't develop it, you'll be left behind. So it's a two-way process. So I think some midway regulation and international cooperation is also required, and that's what we identify in the policy. Geographic information, satellite images, I think there's going to be a regime of international cooperation coming in, because much of this information that's there in one country from one satellite can impact another country in another domain. So all of this will have to be thought of, and some of those thinking we have put it into a report of how that can be done, learning from the past.
Are there questions more? Okay, if there aren't, I just want to have one question. We've talked about downstream applications and the GIS draft for the downstream and so on, and INSAT images used by IMD and so on. So when will we see India having a combined policy of linking upstream and downstream? For example, if today I have to fly a satellite over India, there's frequency allocation that is needed for satellite operation, which is unclear because there is no private frequency allocation band that is available. Or imaging rights, for example, is something that is unclear because that still is in the foray of Department of Space. And for high resolution, there's of course clearance needed from Department of Defense and so on. So on one side, we see that ISRO is the generator of data and mainly also in sometimes user and so on, right, and the processor and so on, and the facilitator in a larger extent. So there are things like GI policy that are in process for the user segment, but when will we see this combination, or is there a platform where we can work towards the combination of that?
I think on the GI side we have identified, but I think on the space side, what to do, and the technology side, I think I'll just say that my colleague will be talking of that tomorrow, so maybe you can get some ideation. Otherwise, I will be preempting what he's going to say. So, but sure. Yes, that's certainly there. Yeah. There is a combination and the integration of these two required. Yeah.
All right. Yeah. If there's any more questions, no. All right. So thank you very much, gentlemen and Lil, for your time. And then, Raji, is there any announcements or?